Alrighty, so we're still talking about variations, but things are going to get a little different. All right. So again, just read the language. That's really what it's all about, and trust yourself. So the first one, what we're going to do for A, B, C, and D is we're going to write the variation formula that's being described. And like I said, some of the language is new, some is different, and we're going to have to make sense of it. So in the first one, it says V varies directly. All right, so that tells me that V equals some constant. What times what? With the square root of t. All right, now be careful, right? Because there's this and there's that, right? This is the square of t and this is the square root. So it's not that one we want, it's that one. So there would be the direct variation between the variable v and the square root of t. And again, it's a multiplication, it's direct, and my constant proportionality is being multiplied to whatever it needs to be multiplied to, in this case, the square root of t. So the language is a little different, but the actual actions are pretty much the same. Next one, f varies inversely. So let's stop there. So this means f equals some constant divided. What is it inversely with? The sum of x and y. Now, sum means addition, and we have to add two things, so x plus y. So that's what it mean. That's what it would mean for a variable f to vary inversely with a sum, right? We're going to basically divide our constant proportionality by whatever that sum happens to be. Like I said, there's a little bit more going on. The idea is the same, but what we're directly or inversely related to isn't just x, right? It's something happening to x's and y's, in this case t's. This one is even tougher because let's read the language, right? It's saying that the variable y varies directly with x. There's the word and inversely, right, with the square of z. So this is what we call a mixed variation problem or a compound variation problem. And rather than breaking it up into two, right, this and statements, we need to put it all together. So y equals, there's going to be some constant, right? That's usually the idea. And in terms of x, it's directly related to x. So that means we have k times x. In terms of the square of z, now remember that means z squared and not the square root of z, right? It varies inversely, right? While it varies directly with x, it varies inversely with the square of z. So that means I'm going to take my k and divide it by z squared. So if I took away the z squared, there's my direct relationship with x. If I took away the x, there's my inverse relationship with respect to the square of z. Putting it together, I have both at the same time. And you got your classic mixed variation, which again, it starts to become even more real life because there's lots of variables in real life. So one more time, and then we'll go do some wordy examples. So in this one, it says f varies directly with the product of m1 and m2. There's the word and, inversely with the square of d. So we have f equals some constant. What's it directly related to? The product, right, means multiplication of m1 and m2. And then divided by, right, because it's inversely, the square of d. Well, that's d squared. And so again, take away the d squared, right, there's your direct relationship with the product of m1 and m2. Take away the m1 and m2, there's your k divided by d squared, so there's your inverse relationship. Of course, put it all together, now f varies directly with the product and inversely with the square. And we've got it. So what about some word problems, right? Well, all I'm going to be asking for here is the constant proportionality. So really of those 4 steps I shared with you, we're really only interested in 2 of them. And then, of course, we'll do some more wordier problems where we look at all. But remember, the first one is to write the relationship. The next step is to plug in what I know to solve for k. And that's what we'll focus on this part since there's a lot of moving parts. So what we have here is f varies inversely with the cubed root of d. So that part says that f equals some k, right? Cubed root, right, would mean that guy right there, right? Not d cubed, right? That's d cubed, and that's the cubed root, right? So we're not saying the cube, we're not saying d cubed, we're saying the cubed root. There's that word right there. So there's our relationship. now, right, there's the information. I'll plug it in. F is 5 when D is equal to 27. So this is 5 and K over 3. If I multiply both sides by 3, it looks like K is equal to 15. And then we can go answer more questions if there was more here, but that's all they're asking us to do. So again, write the equation, plug in what I know to find the constant proportionality. Last one for this handout, or for this video, M varies directly with the difference of the squares of A and B. All right, woo. All right, so again, a lot of information there. So M equals some constant. But this time, right, when it varies directly, it's a product of the difference of squares, basically. A squared minus B squared. So there's my difference of squares, and we're told that M is directly, right, varies directly with respect to that. So there you go. There's your relationship. And what's next is information I can plug in to find K. So we know that M is 10. We know that A is 5. And we know that B is 3. So doing some math, this is 25 minus, oops, that's a square there, you guys. 25 minus 9, we're basically looking at 16K there. Divide both sides by 16, and then doing a reduction, I think 2 goes into each. K is 5 over 8. So for that direct relationship, if M is 10, A is 5, and B is 3, turns out that the constant of proportionality is 5/8. All right, so one more video to do. We'll get a little bit more wordier, do some, I guess, real life problems where all this comes into play. All right, but let me shut this one down, and I'll see you guys in that next video.